Hello dear participants, I welcome you all again here in this certificate course. We are starting our lecture number 21 today, and the title of lecture 21 is Descriptive Statistics, Reading and Interpretation of Partition Value. If you all remember, in the previous lecture, lecture number 20, we tried to understand the meaning of partition value, meaning of quartiles, meaning of deciles and meaning of percentiles. Once we all are comfortable with the meaning of all these concepts, then we can shift to the reading and interpretation of these partition values. So that is the subject matter of this lecture number 21. Objective of this lecture is to make you familiar with the reading and interpretation of partition values which we compute using MS Excel and S.P.S.S. So here are the different measures of partition value. They are quartiles, deciles and percentiles. Now let me start with the first measure of partition value, that is quartiles. So before going to the reading and interpretation part, let me briefly highlight you the meaning of quartiles. What is quartiles? Quartiles are those three values that divide any set of given observation into a total of 4 equal parts. So here actually what we compute? Here we compute Q1, Q2 and Q3, and all these three values, they actually divide your observation or your data set into equal 4 parts. They are very useful concepts in the statistics and in research. So let me take you all to the sample data set where we'll compute Q1, Q2 and Q3, and then we'll try to understand that how can we read and interpret those numbers. So to compute Q1, we use the function or formula quartile, then we select the range and we put a value, we put a number, or we put a number associated with that particular quartile which we actually want to compute. Suppose here if I want to compute quartile 1, then I'll put a number 1. If I go further and if I just want to compute quartile 2, then I'll just simply put the number 2. And if I just want to compute quartile 3, then I'll simply use the same function, but only the change that I'll make is that I'll put number 3 here. So this process part already we have seen in the previous lecture. Fine. Just for the revision, we are just in very brief we are computing Q1, Q2, Q3 here. So once we computed these three things, simply I'll select all these three cells and then I'll go to corner of this thing and then I'll go to the end. I'll drag it to the end. So automatically means that MS Excel itself will compute Q1, Q2, Q3 for different variables. And as you all know that in this sample data set we are having 2 nominal variables, 3 ordinal variables. They are satisfaction, satisc and age C. It's also been considered as a ordinal variable because we have means we coded the age data and we converted it into the ordinal thing. Fine. And third is the scale, that is age is scale variable, height, weight, income, all they are the scale variable. Now let me take you all to the reading and interpretation of quartiles. But for that, first we'll consider the nominal variables, then ordinal variables and finally scale variables, and we'll try to understand that how can we read and interpret quartiles for those respective variables. So let me start with the nominal variable. Now in a nominal variable, again the same thing. For gender, we cannot compute quartiles. No, we cannot compute, and the reason is that here the responses are in words. Responses are means this variable is a string variable. The story is same with the S.P.S.S also. In S.P.S.S also you will not get any result for the quartile deviation if you compute this thing, this variable. Fine. Now we'll shift to the second variable, that is gender C. What are these numbers? These are the numbers computed by MS Excel. Here is the quartile 1, quartile 2 and quartile 3. So what does this number tells me? Now if I'll go back to the meaning part. What is quartile 1? If you remember, in a quartile 1 is somewhere here, quartile 2 is somewhere here and quartile 3 is somewhere here, and these three values actually divide your distribution into 4 equal parts. So here is a 25% part, here is a 25% part, here is a 25% part, and here is a 25% part. Value of Q1, value associated with Q1, it only tells me that from a distribution, 25% of the frequency distribution, 25% of the data is actually less than this number, whatever is the number is. Now here the number is 0. It means that now the 25% of the distribution is less than this 0. But this 0 is actually a code assigned to male. So what is the main feature of this 0, or what is the meaning of this 0? 0 is nothing but a male. Then can I make a statement that from my distribution 25% of the respondents are less than male? Does it make any sense? No, it doesn't make any sense. Story same with Q2 also, Q3 also. Suppose take this Q2. Q2 is again 0. It simply tells me that fine, here is one particular value which is Q2, but the 50% of the respondents or the 50% of the distribution in this data set is less than this value. No, it again doesn't make any sense. Only the thing that we can mention here, that's fine, Q2 is also a median. So a person who stands exactly at the mid of this distribution, his gender is male. So this thing that we can say, that's fine, but we cannot give meaning to this number. So far nominal variables are concerned, don't go with the quartiles. Quartiles, though we are able to compute few kind of some number, but we cannot give meaning. We cannot give meaning here to the results for the nominal variable. For the nominal variables, don't go with the quartiles Q1, Q2 and Q3. Now let me take you to the further slide. Simply it tells me that fine, this 0 is here, 25th, as you remember, fine, 25%. So this value, fine, this value and this value, fine, that's the only thing, but we cannot give proper meaning here. So for nominal variables are concerned, don't go with the quartiles. Now let me take you to the ordinal variable. What about the ordinal variable? Story is same here again. We get the error message because this is a string data. Now what is Q1? Q1 simply tells me that at this position, whoever is the respondent, his gender means his satisfaction level, that coded level is a 2, and 2, if you remember, we coded 2 to the satisfied that thing. Then can I say that 25% of the respondents are less than satisfied? Can we say that? We cannot say that. Reason is that this Q1, Q2 and Q3, the way MS Excel or any software compute it, what does it do actually? It simply observe the distribution and it only identifies the location of Q1, Q2 and Q3, and whatever the value associated to that located thing, that value is represented here Q1. Here the meaning of this 2 is 25% of the frequency distributions are to the left of this 2 if this is coded data. In simple way, so far the ordinal variables are concerned, again here we cannot give proper meaning to these values. No, quartiles are, we cannot use quartiles here for the ordinal variables too. Then where to use quartiles? Q1, Q2, Q3. Q1, Q2, Q3 are only applicable to the scale variable. Here if we look at the scale variable, age is a scale variable. Quartile 1 is a 28. What does that mean? It means that in a distribution of the age, quartile 1 is 28. It means there are 25% of the respondents, 25% of the responses which are less than the age 28. What is Q2? Q2 is 38. What does that mean? This 36, not 38, 36. What does this 36 tells me? This 36 tells me that in this distribution there are 50% there are 50% of the frequencies or frequency distribution, or 50% of the responses that is less than the age 36. Fine. What is Q3? That is 47. What does it tells me? It tells me that 75% of the respondents are having less than age 47 approximately, that we are saying. Fine. Statistics always works with the approximate things. How it works? Let's see. Suppose if I go further and if I plot all these points, all these edges here using these circles. Now, if I want to compute Q1, Q2 and Q3, where they are located. Now, if you remember how we computed central tendency, mean, median, mode in the previous lecture, the way means when we computed all these three things, they are located somewhere here. Fine, in this central part. Fine. Now we are going to identify, or we are trying to understand that where these Q1, Q2 and Q3 are located. We already know that the mean, median, mode are located somewhere here. Now where actually the Q1, Q2 and Q3 are located, and for that if I go further and if I compute Q1, Q2 and Q3, Q1 is a 28, so 25, 26, 27, 28. Here is your Q1. Any point you can choose, that is your quartile 1. And this point tells me that all this part is actually a 20% part, and all these numbers, they are less than this 28 age. Fine. So this is the way that we interpret. Fine. What about Q3? To understand Q3, let me take you here. Q3 is 47. So 45, 46, 47 is here. Correct? Choose any circle. So what this circle tells me? This circle tells me that 75% they are less than this number 47. And remaining 25% are here on the right hand side. But this is a very small data set. Number of observations are only 100. Actually, when we are having 300, 400 sample respondents or thousands, then it is again a very interesting kind of thing. And if you look very carefully, here is your Q1 and here is your Q3 and here is the central tendency. If you look carefully, this is kind of an outlier. Outlier means a extremely high value, or suppose here is a particular number age, that is also known as an outlier. They affect the central tendency, that already we have seen. What is the use of quartiles? Quartiles only tells us the central part, Q3 and Q1. If I minus Q1 from Q3, Q3 minus Q1, I'll get the interquartile range. In interquartile range, all that part we'll see little later. Fine. Now let me take you all to the further slide, and here if I ask you to compare median and quartile, let's see the numbers. Here is say that 36, here is the median, this is again 36, 168, 168. We have computed it separately. Fine. So all the medians, they are same. If you compare these two things, it means your median is always equal to quartile 2. They are like synonyms to each other. This is the way that we interpret quartiles. Now let me take you all to the deciles. What are deciles? Deciles are those 9 values that divide any set of given observation into total of 10 equal parts. Here also, what we try to compute? We try to compute these 9 values. Which 9 values? They are denoted by D1, D2 up to D9. We try to find out these values. Once we find the values, on the basis of this value, we try to interpret the thing. We try to analyze the result. How to analyze, how to interpret, how to read deciles, let's see. Again here is the same sample data set which we used, where we already computed deciles, but again for the sake of better understanding, in a very brief way, we'll again compute D1 and D9, that is first and ninth decile, and for that we'll use a formula percentile. Though the concept is decile, there is no such formula like decile. there is a formula percentile that we use for the decile. Fine. So percentile, I'll select the range and 1 divided by 10. So this thing is very important that we use here, because I am just computing first decile, and for ninth I'll use 9 divided by 10. Then I'll select these two cells and I'll just drag it to the end. Once I drag it to the end, the same formula is applied to all the variables. Now again, let me take nominal variable first, and let me try to read and interpret all these numbers that I have computed. So let me start with the reading and interpretation of the deciles. So here is a nominal variable. Again, here is a error message because this is a string data. We cannot go with this. What is d1? Here d1 is a 0. What it tells me? It tells me that 10% of my frequency distribution or data or my responses, they are less than this value d1, that is 0. Does it make any sense? Can I say that 10% of the respondents are less than male because 0 is actually code assigned to male? No, we cannot give any meaning as such. Correct? Now if I come to D9, can I say that 90%? Because if you remember that here is D1, D2, correct? Equal 10 parts. So it tells me 10%, 10%. So altogether it becomes 90% up to D9. Correct. So this value 1, can we say that 90% of my respondents are means less than 1, and 1 is actually a code assigned to female, they are less than female? Does it make any sense? Again, it doesn't make any sense. If I go further to the ordinal variable, here also I cannot give meaning to these numbers, because this 2, it only represents that fine 2 is assigned to satisfied and 10% people are less than satisfied. No, there are few people who are satisfied too. Fine. And 4, it means if you remember, 4 is a code assigned to very not simply unsatisfied. Unsatisfied is a code that we have assigned to 4. So 90% people are less than this thing unsatisfied. No, it doesn't make any sense. It doesn't make any sense. So whenever you are having nominal or ordinal data, don't go with the quartiles or deciles. Fine. The story is same with the percentiles also. I'll explain you there too. Fine. So I'll go further to the scale variable now here. That's fine. Now the age is a scale variable. Here it is a 19. What does that mean? It means there are 10% frequency distribution or 10% respondent who are having the age less than 19. And where is the D1? D1 is, say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is, say that your D1. So this 10, initial 10%, because here number of observations are 100. Fine. And the formula to compute this is always n plus 1. That is why we count the next one as a D1. Fine. So these all numbers are less than this 19. What does that mean? 10% of the respondents here are less than age 19. Now what about this 52.1? Again, 90% of the respondents are having age less than 52.1. So all they are kind of interesting things. Here we only computed D1 and D9. You can compute D2, D3, D4 and many others. Fine. Now if I come to the graph, fine. Here how to identify D1 and D9, where they are located. For that, if I go further, my D1 is 19 and my 19 is somewhere here. I can choose any one, say that circle, and my D9 is 52.1. Here is a 52.1. I'll choose, say that this one. So here is my first decile, here is my last decile. And what does it tells me? It tells me that the range. So all this part is 90%. So for this value is concerned, correct. All this part is actually only a 10%. If I compute D2 and if it comes somewhere here, then again here is the 10% part, again D3 is somewhere here, correct, and again this will be a 10% part. So all 10%, 10% up to D9, and the remaining is a 10%. Fine. So this is the way that it looks like, and that's the meaning of deciles. I hope you understood this. Reading and interpretation of other variables, again same thing. 48.9. So there are 10% of the respondents who are having less than this age. Fine. If I come to the per head income, 90% of the respondent having per head income less than 16,275. Fine. Income, 90% of the respondent having salary or income less than 60,200. So this is the way that you can simply go ahead and you can read and interpret deciles. Fine. I hope you understood this thing. Now let me take you all to the last part, that is percentile. What is percentile? Percentile are those 99 values that divide any set of given observation into a total of 100 equal parts. If you remember that this part already we have seen in the previous lecture, the meaning of percentile. Here actually what we compute these 99 values. P1 we compute, P2, P35, P94, P98, any value, right, that we try to compute, and we try to find out that positional value below which that particular percent of the respondent they lies below that particular value, or they lies above that particular value, and then that we interpret that thing. How to read and interpret this thing? Again come to the percentile, and here I'll only compute only one percentile, and that is the 92nd percentile, and for that again I'll use this function percentile. I'll select the range and I'll use 92 divided by 100, because here I just want to compute 92nd percentile. Fine. Now if you want to compute 83rd, then you will have to mention it here, 83 divided by 100. All this part, process part, already we have seen. Simply I'll press enter and I'll drag this cell to the end, and I'll get the 92nd percentile for all my variables. Now let's again consider the nominal variable, and let's see that how can we read and interpret the percentiles. Correct. So here is the nominal variable. Again here, what does this number tells me? This number 1 is only located at the serial number, say that 92 or 93 in a distribution, and his this is a code assigned to female. It only tells me that that's fine, a person who stands at this position, her gender is female. But can we say that 92% of the respondents are less than female or less than 1? No, we cannot give meaning like this. Again the things are, so far the nominal variable is concerned, we cannot give meaning to any partition value. We cannot give any meaning to any partition value. Fine. Now the story is same with the ordinal variable. Here also we cannot give meaning, no meaning. So far nominal and ordinal variables are concerned, don't give or don't treat them using any partition value. Now if I come to the scale variable, here is 53.08. I can simply say 92% of the respondents are having age less than 53.08. Now here question comes that whether that value is there in this data. Is it visible? It is not always necessary that your partition value is visible. If your data is small, it is not visible. If your data is huge, there are many respondents, then there are more chances that your partition value is located there. Partition value actually works with the continuous frequency distribution, and this value is only the approximate thing. Fine. So 53 is somewhere here. Here is 92, that is P92. here is 53. So 92% of the respondents are less than age 53. So this is the way that we can interpret this thing. Fine. So let me again show you here where this P92 lies. Where does this 53 lies? So it is here, and what it tells me? It tells me that all this frequency distribution, it tells me that 92% of the responses, they are less than this P92, and P92 is nothing but 53.08 that we have computed here. So computing this thing is simple. Computing this thing is simple, but giving meaning, how to interpretation part, it is quite interesting. It is quite interesting. So that is the way that we read and interpret. So here are again other variables too. So as I mentioned, never ever try to give meaning to these things. So far the quartiles and deciles and percentiles are concerned. So don't go with this. Also don't go with this. Fine. That's fine. We can interpret things here. So for the scale variables, we can interpret the things here. We can interpret these things. Fine. Like income, 92% of the respondents having salary or the income less than 65,000. So this is the way that we can interpret. So I hope you understood this lecture. In this lecture, we try to understand that how can we read and interpret partition values. In the next lecture, we'll start with the dispersion. Thank you for your kind listening. Thank you.